In this example, we will be trying to find the intersection of the two given lines. So we are given line L1 and L2. These are the parametric equations of L1, and these are the parametric equations of L2. The ultimate goal here is to find the intersection of L1 and L2. Now notice that I have used the parameter t for L1, and I have used the parameter s for L2. The question is, why did I use different parameters for the two lines? So that is, why did I not use t instead of s in the equations for L2? The answer is, if we use the same t here, we may not get the correct answer. Here's why. So recall that the parametric equations of a line can be thought of in the following way. So we can think of L1. We can think of XYZ as the position of a moving bug at the time t, and also we can think of this XYZ as the position of a moving bug at time s. Now imagine that the paths of the two bugs, so they are moving on straight lines, and if their paths intersect, then notice that it's not necessary that the two bugs come to the intersection at the same time. They may come to the intersection at different times. So as a result, we shouldn't be using the same parameter t in both of the equations. So if we use the same t, then we are assuming then the bugs come at the intersection at the same time, which they may not. Okay, so the first question is, given the parametric equations of a straight line, how do we find a point on the line? Well, how can I find a point on L1, say? Well, to find a point on L1, you just pick any value for the parameter t. So if t is 0, then notice that x would be 1, y would be -2, and z would be 4. So 1 minus 2, 4, that would be a point on the line L1. Again, we don't have to use 0. We don't have to plug in 0 for t. We could plug in any other value for t. So for example, if I plug in 1 for t, then x would be 2, and y would be 1, and z would be 3. So 2, 1, 3 would be another point on the line L1. Okay, so now question number 2 is, find a vector that is parallel to the line L1, and find a vector that is parallel to the line L2. So how do I find a vector that's parallel to L1? Well, recall that the coefficients of t are the components of a vector that's parallel to L1. So if I look at the coefficients of t, 1, 3, -1, that's a vector which we're labeling as v1. So v1 is parallel to L1. Now, similarly, if I look at the coefficients of s here, 2, 1, and 4, then that's what I'm denoting by v2, and v2 is a vector that's parallel to L2. Now, is L1 parallel to L2? How do I answer that? So the question is, are the two lines parallel? In order to answer that, we just have to check whether the vectors v1 and v2 are parallel. Well, how do I check v1 and v2 are parallel? Well, I can take the ratio of the corresponding components and see if we get the same ratio. We get half, 3, and negative 1/4. Well, we don't get the same ratio, so therefore L1 and L2 are not parallel. Now we want to know, do they intersect? Well, in R3, two straight lines may not intersect. So, in R3 we may have a situation where the two lines they lie on parallel planes, but they are not really parallel either. So that is, you see the line L1 with the parallel vector v1, the line L2. So here I have the line L2, which is parallel to the vector v2. So v1 and v2 aren't really parallel vectors, but notice that L1 and L2, they lie on parallel planes. So these lines are called skew lines. These lines are not parallel, but they don't also intersect. So they are called skew lines. So going back to our example, the question is, the given L1 and L2 here, do they intersect or not? And if they do, then we want to find the intersection. Well, we're just going to go ahead and assume that they intersect, and then we're going to try to find the intersection. And if we can find the intersection, then they intersect. If we cannot, then it'll mean that they don't intersect. So if the two lines intersect, so going back to the two equations, if the two lines intersect, then there has to be an S value and a T value, T naught, so there must be an S value, S naught, and a T value, T naught, so that the XYZ coordinates of the two lines match. So in other words, at the intersection, the X coordinate of line 1 should be the same as the X coordinate of line 2. And the Y coordinate of line 1 should be the same as the Y coordinate of the line 2, and so on. So let's say, so that means to find the intersection, what we're going to do is we're going to set the x's to equal each other, and we're going to set the y values equal to each other, and then we'll try to solve for s and t. So we're going to set 1 plus t to 2s. We're going to set minus 2 plus 3t equal to 3 plus s. Okay, so if we do that, we get 1 plus t is 2s minus 2 plus 3t is 3 plus s. The first equation can be rewritten as t minus 2s is equal to negative 1. The second equation can be written as 3t minus s is equal to 3 plus 2 is 5. So we have this system of equations, and we need to solve for s and t. One way to do that is we're going to keep the first equation as it is, and then we're going to multiply the first equation by negative 3 and add it to the second equation. So if I multiply the first equation by negative 3, so if I multiply negative 3 here, then when I add, t will cancel out. When I multiply here by negative 3, then I'm going to get positive 6s added to negative s will give me 5s. Negative 3 multiplied by negative 1 would be positive 3, plus 5 would be 8. So then I see that s has to be 8/5. Now once I have that, then I can plug the value of s in the first equation. So t would be 2s minus 1. S is 8/5, so I get this, which eventually is 11 over 5. So we get that t is 11/5. So we see that when s is 8/5 and t is 11/5, then the x and y coordinates of the two lines match. We still have to check whether the z coordinates match. So going back to the equations of the lines, we see that z is 4 minus t here, and z is negative 3 plus 4s. So so z is 4 minus t here. We plug in t to be 11 over 5, and we get 9/5. And for the line 2, z is negative 3 plus 4s. We plug in 8/5 here, and we get 17 over 5. Well, the z coordinates don't match. So what are we saying here? We are saying that the only values of s and t for which the x and y coordinates of the two lines match are 8/5 and 11/5. But for these values of s and t, the z coordinates don't match. So as a result, we see that L1 and L2, they don't have an intersection. But if we found that at this stage, if we got the same z coordinates, then we know that L1 and L2 will intersect. Now, in that case, how do we find the intersection point? Well, once the z's match, then I can say, well, there is an intersection. Then what we could do is we can pick, one of either the s or the t value. So let's say I pick the t value, and then I can plug that in here and solve for x, y, and z, and that's going to be the intersection of the two lines. Again, two lines that are not parallel and do not intersect are called skew lines. All right, so we will stop the discussion here. In the next video, we will be doing another example.